Welcome to the DIY Honda Garage channel. The diagnostic trouble code, DTC P0843, pertains to the transmission fluid pressure sensor switch, A circuit high. It indicates an issue in the electrical circuit of the CVT or the continuously variable transmission in your Honda CRV, manufactured between 2017 and 2022. Rather than a mechanical fault within the transmission itself, this code signals an electrical issue that must be addressed. The CVT fluid pressure sensor plays a crucial role in monitoring the hydraulic pressure in the transmission system, thus affecting the overall shift quality and performance of the vehicle. The sensor's location is typically on the transmission case, directly connected to the transmission fluid and the electronic control unit, ECU. Accurate readings from this sensor are essential for efficient operation of the CVT. And if the readings are outside expected parameters, the vehicle may exhibit symptoms that impact drivability. The P0843 error specifically denotes an electrical circuit issue related to the transmission fluid pressure sensor. Unlike mechanical failures in the transmission, this code directs focus to electronic signal problems. Located in the CVT system, the fluid pressure sensor transmits crucial readings to the engine control unit, ECU, which dictates the operation of the transmission. If the sensor detects a pressure level above the normal value, it sends a high signaling voltage which culminates in this DTC being logged. This pressure sensor is vital for the vehicle's performance. Any abnormalities in its readings can lead to transmission slipping or erratic shifting, thereby impacting overall drivability. Therefore, proper diagnosis of this system is critical to ensure reliable vehicle operation. The potential causes of DTC P0843 mainly stem from electrical issues rather than mechanical failures. Poor connections could mean loose or corroded terminals, which hinder the proper signal transmission between the sensor and the engine control unit, ECU. Damaged wiring can also lead to shorts or open circuits, resulting in erratic voltage signals. It is not uncommon for the fluid pressure sensor itself to be faulty. Sensors can wear over time or suffer internal malfunctions, producing incorrect readings. Each of these issues can prevent the sensor from functioning correctly, which results in the P0843 code being triggered. By thoroughly checking these elements, you can isolate the problem effectively during the troubleshooting process. Symptoms of DTC P0843 may manifest as erratic shifting patterns, where the transmission fails to shift smoothly or correctly, impacting driving comfort and vehicle performance. You might experience an increase in engine RPMs without a corresponding increase in speed, which can be a direct result of the incorrect pressure readings from the sensor. Additionally, the illumination of the check engine light is a clear indicator that there is an issue with the vehicle's performance that needs to be addressed. Drivers may also notice a decrease in fuel efficiency, causing further inconvenience and expense. It's vital to address these symptoms promptly to prevent further complications within the transmission system. The first step in troubleshooting DTC P0843 involves turning the ignition to the on mode without starting the vehicle. This enables the vehicle's onboard diagnostic system to activate and allows you to use the Honda Diagnostic System, HDS, for further checks. After setting the ignition to on, the next requirement is to clear any existing DTC codes, which helps in refreshing the system's memory. Following this, it is crucial to inspect various parameters using the HDS. Specifically, the driven pulley pressure sensor value should be more than 4.84 volts, as this indicates a normal operation. If the current conditions do reflect this threshold, it signifies a duplicated failure of the DTC, prompting the technician to move further in troubleshooting. Conversely, if the values do not match the threshold, it often points to intermittent issues and further inspection for loose connections or wiring problems is advised. In the second step, begin by turning the vehicle off to safely disconnect the associated components while preventing any electrical damage. Locate the CVT-driven pulley pressure sensor 3P connector and disconnect it from the sensor. Once disconnected, you will take jumper wires to connect terminals A and B of the 3P connector, essentially creating a loop. By re-energizing the ignition to the on mode and using HDS again, you need to verify the voltage levels of the driven pulley pressure sensor. The expectation remains that the voltage should exceed 4.84 volts. If this is confirmed, it indicates your transmission fluid pressure sensor may still be in working order and advises you to proceed to the next troubleshooting step. If not, this may highlight problems deeper within the system that require further inspection. For the third troubleshooting step, turn off the vehicle again to ensure safety and disconnect the jumper from the terminals. Next, it's crucial to jump the SCS line using the HDS, which protects the engine control unit, ECU, or powertrain control module from damage during diagnostics. Once the SCS line has been jumped, disconnect the PCM connector C, which contains 51 pins. At this point, measure the continuity between the test points to ensure that the PDN wire, which transfers data signals between the CVT-driven pulley pressure sensor and the PCM, is functioning correctly. You need to ensure continuity is present by using appropriate measuring devices, and if continuity is found, it confirms that the wiring is intact, guiding you to check for other issues pertinent to the symptoms you're diagnosing. If no continuity is detected, this indicates an open circuit in the PDN wire and will require repair. In the fourth troubleshooting step, again, start by turning the vehicle to the off or lock position to ensure all electrical systems are properly reset before testing. Following this, the jumper wire must be removed and the ignition turned to the on mode. Proceed to measure the voltage between the specified test points in the disconnected CVT-driven pulley pressure sensor 3P connector. You should aim to find a voltage reading that is around 5 volts. If this condition is met, it suggests the sensor is indeed failing and requires replacement, as it indicates that it's not delivering accurate voltage signals to the ECM, impacting transmission operation. Conversely, if the voltage reading is not approximately 5 volts, it indicates that the issues could stem from the power supply circuit instead. The final troubleshooting step involves closely inspecting the power supply circuit to the fluid pressure sensor. While in the on mode, measure the voltages between the designated test points. Point 1 is at the CVT connector for the pressure sensor, while point 2 is grounded at the body. A correct power supply should measure near 5 volts. If this condition holds true, it indicates an issue with the SG2 wire running between the sensor and the PCM, which must be repaired. Conversely, if the voltage is not around 5 volts, attention must turn to the VCC2 wire. Identifying which wire is at fault will be essential for restoring proper function to the transmission fluid pressure sensor circuitry and ensuring accurate feedback for the system's operation. To ensure that the repairs addressing DTC P0843 have been successfully implemented, it is crucial to conduct a thorough verification process. This includes clearing the DTCs from the vehicle's memory after all necessary repairs have been made. Once cleared, a test drive should be conducted to monitor vehicle performance under normal operating conditions. During the test drive, pay attention to any erratic shifting or abnormal transmission behaviors, which may suggest that further examination is necessary. If the check engine light remains off and the vehicle performs properly without recurring DTCs, it confirms that the repairs were effective and the underlying issue has been resolved. This is the final step to ensure a reliable and safe driving experience in the Honda CRV. Preventive maintenance is key in avoiding future occurrences of DTC P0843 and maintaining peak performance in your Honda CRV. Regular inspections of wiring and connections related to the CVT fluid pressure sensor can identify potential issues before they become problematic. Ensuring that the sensor is functioning properly and the fluid levels are correct can help mitigate wear and tear on the transmission components. Additionally, consider routine checks during servicing that clean any debris or corrosion buildup at connection points to enhance conductivity and signal integrity. Maintaining proper fluid levels is also essential, since low fluid can cause false readings and affect transmission performance. Establishing a routine maintenance schedule will help safeguard against this DTC reappearing. In conclusion, understanding the implications of DTC P0843 is vital for maintaining your Honda CR-V's transmission performance. As a code linked to electrical issues around the transmission fluid pressure sensor, the diagnosis must focus on electrical assessments rather than mechanical faults. By following systematic troubleshooting steps, it is possible to identify and rectify the underlying causes efficiently. Additionally, preventive maintenance actions can significantly reduce the risks of encountering similar DTCs in the future, as electrical components are susceptible to wear and environmental factors. By being proactive, ensuring all electrical connections are robust, and regularly verifying sensor functionality, vehicle owners can enjoy a smoother, uninterrupted driving experience. Please like and subscribe to the channel. See you next time.